welcome to another week on Learn All Things Cyber with T. So it's been quite a tough ride from, networking, IP addressing, IPv4. We did a simple mathematics. We also tried to convert the dotted decimal to binary. We went into subnetting. I talked about what sideout notation means. And so this is the last part of, the episodes on computer networking. And I would like first of all to talk about the difference between a private IP and a public IP. So what is a private IP? They are IP that are usually reserved for your local network, like the home, like the office, within the confine of, communication within your network. They don't have to be routable from the outside. So somebody cannot, use any of these IPs to route to you from the outside through the internet. That's what private IP means. And I would be sharing with you all of these ranges. And then public IP means everything outside of private IP. So, I divided, when we're talking about subnet mask, we had this class A, B, C. So within class A, there are parts that are reserved for private IP ranges. And within class B, there are also some parts that are reserved for, private IP ranges. And for class C, we also have some parts. And so for class A, we have this 10.0.0.0 to 10.255.255.255, and the sideout notation is this. So you remember I said that with this sideout notation, you'll be able to know, the type of usable IPs that you have. We have B also from 172.16.0.0 to 172.31, not .16 but to 31.255.255, and then this very popular one that we've been using as example, 192.168.0.0. These are like private IPs, and again, like I said, no one can route to you from outside, like through the internet. And every other thing falls within the public IP, and they are usually assigned by the ISP, Internet Service Provider. I think I had mentioned before in some of my videos what ISP means. So because we have these two batches of IP, how then do we communicate with, let's say you want to browse on google.com? How then can you use the IP of your device that have been assigned to your device to get this information through the internet? So this is the case where we have something that we call, we call it NAT. So we have what we call NAT. So what is NAT? NAT is a network address transmission. So what does NAT do? To private. So what does NAT do? Like I said, NAT is network address transmission. So let's say, for example, you're trying to browse what is google.com, google.com on your laptop, for example, and your laptop has been assigned a private IP in your network. And sometimes you can use something called DHCP to dynamically assign you IP. Or you can, be assigned statically, and I would explain this further in the lesson. So, say for example, your IP, the private IP of your laptop, is requesting information to get, google.com. The ISP assigns you a public IP. So it's this public IP that goes out to the server, to the web server, to get the information of what you need. The public IP have this information. They send it back to the private IP before you get the information. So let's say, for example, google.com, /get me a buyer or something like that. On the internet is this public IP that will be visible. Your private IP will not be visible. The public IP will get the information you need, transfer it to the private IP before you get that information. So your information, this private IP is not supposed to be visible anywhere public, and it's the same for workplaces also. From the internet, you're not supposed to be able to communicate with that IP, but from intranet within the company, communicate with each other. So I hope this explains what is the difference between private and public IP. So after talking about private and public IP, I'd also like to mention that there is also something called static and dynamic IP, and I will explain it in a moment. So what is static IP? It's an English word. It means that something is permanently assigned. So it means, for example, a printer that needs to be reached constantly in an office or in a home. You can permanently assign an IP to the printer or to a server. Also, you can permanently, because the server needs to be reached at all time. Like, you cannot afford to keep changing the IP of the server. So usually static IPs are assigned manually to devices. They are assigned manually, manually assigned. They are permanent. They don't change over time, even if you restart things or anything. They are permanently assigned. And also they are usually assigned to things like servers or network printers that needs to be reached constantly, and you can't afford to keep changing their IP. Now, what about dynamic? It's the opposite of static. So dynamic IPs are the one that changes over time. When you restart your router, they usually change, and it's good in a way that you don't have to manually enter in IP address for your devices. It's also good because it helps you to fight against IP conflict. Say, for example, let's say your laptop is 192.168, maybe 1.6, and then your phone is 192.168.1.7. Your phone cannot take up .6 again because you already have it in your laptop, and that's what the dynamically assigned IP does, and is usually using something called DHCP. And so DHCP is Dynamic Host Configuration Protocol, the assigned IP, and they can also assign subnet mask, and they are temporarily assigned. Like I said, unlike the static one, they can change over time. Like when you start your router or something like that, the IP can reshuffle itself and change over time. So those are like the two differences between static and dynamic IP. I hope that explains it. So another part of IP that I would like to explain is also the difference between a broadcast address and a multicast address. So broadcast versus multicast. So what is the difference between these two? Now, for a broadcast address, I will try to explain in the context of day to day. So for example, I'm looking for somebody, maybe the name of the person is Steven, for example, and I get into a room where we have like 20 people, and I shouted, "Steven, where is Steven?" The 19 other people in that room don't need that information, but because I needed to look for Steven, and Steven needs to identify himself, so I'm screaming to every other person in the room. So what broadcast address does is that it broadcasts an information to every device on a network. Say, for example, I want to broadcast something to every device in my network. It's like my laptop will receive the notification, my phone will receive it, my smart TV will receive it, and all of that. That's for broadcast address. And the use case for broadcast address will be ARP request. What is ARP request? So ARP is Address Resolution Protocol, and what ARP does is that it tries to look for a MAC address of a device by putting out the IP address. Say, for example, I want to get the MAC address for my laptop. I'll just say, hey, I'll broadcast to everybody and say, oh, who has this IP address? Can you forward me your MAC address? That's what ARP request does. So again, it's a use case for broadcast. It broadcasts to every device on the network, show them the IP that it has, and ask them to forward back their MAC address. So for multicast is like, we would say it's similar to broadcast, but in this case, it doesn't broadcast to every device on the network, but rather to a group. Say, for example, if you are subscribed to a particular multicast group, then you get that information. Let's say 5 people is subscribed to a particular group, you will get the information when a multicast, address sends out a message. And the use case for this one is like, streaming audio or video to a particular group in a network, not to all the devices, as opposed to broadcast in the network. And I hope this is you know, a better explanation for this. Now I'll quickly just talk about loop back. So because you could also encounter loop back in your exam or question. So there's this IP.1. We call it a loop back IP. And what it does is it just communicates with yourself. It's like saying, hey Tope, how are you doing? I'm talking to myself and I'm addressing the question back to myself. So that's what loop back does. Developers usually use it to test their own software on their own machine, and sometimes you can also use it to check if your network stacks are working. So I just decided to mention this just in case you come across it, you would also know that it exists, and it's called loop back address. And I hope this video has been useful. See you next time. Thank you.